Hi, in this video we're going to take a look at an update to one of my command line tools, which is called fixed digits. And basically let me jump right in and start talking about this. Essentially, up until now, fixed digits has been a tool to add leading zeros to numbers in file names. So for example, if you have a folder with files named like this, you can see that if I just for example, use a less on it, they appear out of order, and you might wish to have these numbers zero padded so that there's always a leading zero, and essentially that all the numbers are equal width. And basically, yeah, so but writing a one-liner in the terminal every time you need to do that, specific to each set of files, is kind of complicated. So I decided to write this tool. Essentially, by default, if you just run fixed digits on a folder like this, it will add leading zeros, as you can see here. So this is also a simulation. In order to run the operation for real, you need to pass -r, but I'm not going to do it just now. So this has been basically the main function of this tool up until now. But I kind of then thought about it more, and I came up with some other things that you might want to do with a set of numbered files like this. For example, you might want to reorder them. You might want to increment or decrement the entire set, for example, shifted by 2 or something. If you want to add 2 extra files in the beginning, something like that. And also you might have gaps in this sequence. So for example, maybe there was no fourth and no fifth, and you wanted to basically close that gap so that the next number after 3 would be like 4, basically, so that you can just collapse it and there would be no gaps in numbers. So those are basically the three things that I'm going to talk about in this video. Those are the new features that I added to this tool. Let me also open a new tab here, and I'll open the man page for this so that we can have that as well. So first, before we start talking about all those new features, let me talk a little bit about what I changed with regards to the old features, or mostly I just added things basically. So up until now, since zero padding has been the only function of this tool, there was no need to disable zero padding. But now that you have this kind of more broad set of features, you might want to not zero pad. So basically, this is the default behavior. By default, it will zero pad just like it has been doing up until now, but you can pass -Z to disable zero padding, so it won't add any zeros at all, unless they are already there. I'm going to talk about it in a moment, unless they're already added to the file names. But if you just have files with no leading zeros, this is what you'll get. You can also use -z, and you can pass an integer to it, so it takes an optional argument. You can pass an integer to it, for example 2, or let's do 3. So in this case, it will pad everything to 3 digits, so you will get this. So if I pass 2, it will be just the same as the default, but there's a difference here because the default is actually auto. So if I just pass -z, that's the same as the default behavior, but you might change that default behavior in the config file, for example, which I'll talk about in a moment. Let me not get sidetracked. Basically, if you just pass -z, it's the same as just passing -z auto, which what it does is it analyzes the set of files, and it determines how many zeros to add, so that everything is it will add as much as needed, so that everything sorts correctly, basically. So that's that. One thing to basically the next yeah, the other addition that I did to this zero padding functionality is this zero-pad-normalize option. So basically what that does, for example, if I had, let me create another file here, and I will call it 011 11th. So this is what we have now. And basically now if I run it as it is, it will see that like, okay, it has like 011, so I will see this is like z auto. That's what I mentioned. It's the same as this. So it just sees that like the widest number here has 3 digits, and so it pads everything up to 3. But you might wish to kind of get rid of that extra 0 there, so in that case you can pass -n, and that will normalize that, which means basically it will remove any existing zeros first, and then it will start adding things. Yeah, that's basically the thought there. So that it first removes the existing zeros, and then it adds more if needed. Also, if I let's say did not want to add zeros, if I do this on this set of files, you can see that 011 stays 011 because this just tells it to not add leading zeros. But if you want to get rid of that 0, you also need to pass -n so that it removes the existing zeros before doing anything else, basically. In this case, there's nothing else to do, or like sort of like not add leading zeros, skip the adding of leading zeros. So these are the additions to the zero padding functionality, essentially. So now, yeah, like I also renamed these options to match before and match after. They used to be called before and after. This is just to make it sort of like more organized and just like more descriptive. Also, the -r is now called --run instead of --rename, because I have other tools that sort of like use this -r option in the same way, that like without the -r it's a simulation, with the -r it runs the operation for real. So I just decided to use as a generic name. But yeah, those are like small things. I guess like while I'm on the topic of these smaller additions, let me just kind of throw in and explain what this print-cmd does as well, or rather show you. It's very simple. It's simply will tell you what commands will be run when once you execute everything. So as you can see, it just like explains what it's gonna do. And this is a simulation. If I pass R, let me just rename them here. So basically you see that like different colors appear, that just to make it clear that it's a different kind of operation that it's running, and this is highlighted in green instead, and the commands are also have different colors. I'm not sure, I might change this color scheme. I'm just like I just put this for now, but yeah, this is how this works. So now everything has been renamed, as you can see. So let me undo this, remove the 11th file, and I will let's see, what do I need? I need to just normalize everything and not add any zeros. And now I'll do this, and basically yeah, I'm back to where I started. So that's how that works. Now so I talked about the print-cmd. So now let's talk about the two simpler operations, which are shifting or incrementing or decrementing, and removing gaps, because those are very easy. And then we'll talk about reordering, which is a bit more involved but also very intuitive to use. So yeah, let's start with the simple thing of incrementing and decrementing. So the option is --shift or -s, and you can add either a positive integer or a negative one, so or a 0. So it's very easy. Let's see. So this is our set of files. If I run fixdigits-s1, for example, it will just increment everything by 1. And if I pass, like for example, -1, it will decrement everything by 1. So you can see that there's also like an extra column here now, and this column just shows what, like in which direction the numbers were shifted. So this just means that like it went 1 down compared to what it was. This used to be 1 first, 2 seconds, so it went 1 down. And this quote, it's like a ditto mark that just shows that this is repeated. So it's all one down, 1 down, 1 down, 1 down, 1 down, etc. You can, if you want, just like a quick word on the config file, you can go into the config file, which is provided in the repo. So let me see. Here is the root directory of the repo, and here we have the config.bash. It looks like this. So everything is commented out, and you can just put this file into the folder called home.config fixdigits. Put it there, and this is what I have here. And basically this part controls the color scheme. You can try and mess with that if you want, but what I wanted to show here is that in the symbols section, you can see that you can change those arrows that appear here if you prefer, or maybe if something doesn't work, like maybe you have some font that doesn't have them for some reason, or like something like that. What I wanted to show here though is this ditto mark. So you can remove it and save the file. So, and if I run it now they are just repeated. I personally find this very hard to look at because it's just the same thing over and over again. So I prefer to have like a symbol there to represent that. But this is just an option that you can enable or like disable the ditto. So everything just is output literally, all the repetitions. So that is the shifting or incrementing or decrementing. So again, just to like a quick recap, just S with the number of however many by whichever amount you want to shift it, and just enter that number and it does it. So that's all there is to it. Now let's talk about removing gaps. So the option is called -G, preserve gaps. So by default it preserves gaps. So let's first of all create a gap. Let me remove file number 3 and 4. So now we have this. So if I run fixdigits on this, just with no options, with the default settings, you can see that it goes 1, 2, 5, 6, 7, 8, etc. But if I use the no preserve gaps option -G, that results in the gap being removed. We can again see this number that shows by how much this everything was shifted. So basically, since there was a gap, everything from this point shifted by 2 upwards. So yeah, there we go. That's removing gaps. It's very simple. That's all there is to that. So basically, we've covered all of the like simple stuff, and let's talk now about reordering. And it's not that it's complicated, it's just a little bit like if there's a few more things to know about it, basically. Yeah, let me actually put back those files that I deleted so that we have the full set. So yeah, now reordering. So Basically, in order to change the order of the files, you need to pass -o. Oops, -o. So now if you press enter, you get a text editor. A text editor opens, and you can move things around here. So for example, if I wanted to swap 3 and 4, I can just swap those lines, then save the file and quit, and they get reordered. So this is kind of the basics of how this works. There's a lot of kind of things that you can customize here. I don't know if I'll go through everything, but I'll go through a couple of things. Well, I guess like the easy thing that I can talk about right away is just that you can set a text editor of your choice. If you don't change anything in the default configuration, the visual and editor environment variables will be analyzed, and the value will be determined based the text editor that it will use will be determined based on that. If none of those are set, nano will be used. So you can read more about these environment variables over here and how they are like assessed and in what sequence. So yes, that's the editor. Now let's take a look at how gaps are represented in the reorder file. So yeah, so we ran this operation. Right now I'm going to do something that I'm not going to explain right away, but basically I'm going to clear the temporary reorder file that got generated while we're editing this by running fixeddigits-x. I will come back to it later. But right now let's just take a look at how gaps work. So I will create a gap by deleting the files 3 and 4. And I will run fixeddigits again. And so now we can see that what got generated is this. So the gaps were represented with these special comments in the reorder file. And essentially the way they work is the same as the lines that present files do. So you can reorder files like this. So you can move the file even between the gaps, and the order will still be respected. So I just moved this file into the position number 4, and we can see that in the output it was moved to 4. So the gaps work, the gap lines and the file lines work the same, essentially, in terms of how reordering happens. So that is gaps. So let me now restore our original file set by recreating the 3rd and 4th files. So yeah, and I'll delete that temporary reorder file that we just edited again. I'm just about to explain how this whole thing with the temporary file works. So, but right now I just wanted to come back to this original example that we did. So right now we don't have any reorder file, we didn't do any reordering yet, and so let's do it for the first time. I'll run fixeddigits-o on the set of files, and I'll move some file somewhere else, save it and quit. So now we have a temporary reorder file there in the cache directory. So that's the location of that is home.cache fixeddigits, and the name of the file is reorder. So now look what happens when I run fixeddigits-o again. So if I run it again, the text editor doesn't open up for the second time. It just runs the simulation against that already existing temporary file. So the thought behind that is that you can now open that file somewhere else in a text editor and continue working on it. Let's say I move another file, and now I can keep previewing it until I'm satisfied with the result. And once I am, I can go ahead and rename them for real by passing -r. And once I do that, now the temporary file gets removed. So this is the default behavior. Now let's take a look at what options control this. So when it comes to whether to keep or to delete the reorder file and when to do that, it is controlled by this reorder-file-keep-temporary option. Yeah, the default value is auto. Like we just saw, it keeps the reorder file when simulating the operation, but deletes it when actually renaming the files. And the other possibilities are always and never. In which case, if you say that always, the file always gets kept, and never gets kept, so it gets deleted even if you are simulating. Then the reorder-file-edit option controls when the editor opens. So again, the default value is auto, and it edits the reorder file when it's generated for the first time. And but if it's already there, it doesn't open the editor for you for the second time, so you don't have the editor popping up constantly while you're editing it. The thought is that like you'll open it somewhere else and you will just keep previewing it there until you're done. So this is the default behavior, the auto behavior. And the other two possibilities again are always and never, to always edit it or never edit it. So that's how that works. And when the value is enclosed in square brackets like this here, it means that you can actually omit that argument. So when you just pass -e without any argument, it's the same as passing -e always. And I was just gonna show you an example of this, like how this can be helpful. For example, so I just kind of messed up my set of files here and rearranged everything. So let's say I want to work on it again, and so I will generate another edit or a reorder file, and I'll rearrange everything like it was. And so the preview looks good. It's first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. The order is correct. And now basically if I were to, you know, like the thought is that you will open it somewhere else, but maybe you just want to open it again anyway, then you can just pass -e and it will open it for you to edit again, and then you can close it. So it's always there for you if you want it, but if you don't want it, you don't need to have it pop up all over again. So yeah, and so that's an example of using -e always. So it's the same as doing always. There we go. So let me see, I'm going to clean this up and restore our original set. So I will do -o with that file that I just did, with rearranging everything back to the original order, and I will normalize the zeros so that they are removed from the already existing file names, and then not add any zero padding, so that we are back to our original file names. There we go. So now let's take a look at this third option that controls things when it comes to the workflow. And basically what this does, so to demonstrate this, I'm gonna again come back to our original example of just like having this original file set and doing -o and swapping the third and the fourth, and then quitting. So let's say I did this and I didn't rename anything. I just did that and I forgot about it. Then now there's like this temporary file sitting there in the temporary folder. There it is, but I forgot about it. So, and let's say I go to some different folder where there's a different set of files. And yeah, let me just create a temporary folder. Let me see. So, and we'll do just mkdir6. Change there. And I'll do touch 1 to 10 dash test. So a different set of files. Now, so remember that we already have this temporary file there sitting in the cache folder with this content, right? So, and we have this in our current directory. This is the file set that we're gonna run this everything on. So let's see what happens when we do -o on this. So it generated a new file. It cleared what was in cache. So essentially, the behavior is that it checks if the current file set matches what is in that reorder file and in the temporary directory, and only if it matches will it go ahead and use it use it to apply it to the current set of files. And if it doesn't, then it will delete it, and from that point on it will just generate a new one that will work for the current set of files. So this is what this reorder-file-clear-temporary option controls. The default behavior is auto, and this is what it does: delete the reorder file if it does not match the current file set, otherwise keep it. So in all of our previous examples, it was just keeping it because we were working on the same file set and it was always matching. But now I moved to a different folder with a different set of files. The file names didn't match, so it went, oh, okay, that's a temporary file, I can chuck it, and I can create a new one so that you can work on your operation. So the other options here again are always and never, and there's also prompt, which is the same as auto, but before deleting anything it will ask you. So I can show you how that works. Let me see. So I guess I will just go back to my original folder, and again I'll just run fixeddigits -o and generate a file for that set, and then go back to our folder with our second set. So this is what we have in the temporary file now. This is what we are gonna be running this on. And if I run fixeddigits -o -x always, or not always, but prompt, there we go. It will ask you, will tell you that the temporary reorder file such and such seems to come from a different file set, and it should be okay to delete. Would you like to delete it? And it will gives you three options: Y to delete it for yes, N for keep it for no, which is the default. If you just press enter, it will keep it. And also O to open it to see what it is. We already see it here, but let's say we didn't see it, so you can open it and take a look and see, okay, I'm good to delete this. Then you quit that text editor, and it just asks the same question again, and then you can say Y, press enter, and the new file gets generated. So that's the prompt behavior. Essentially, this is almost everything when it comes to the workflow. One other thing to just quickly mention is that you can specify a custom location for a reorder file, and if you do that, it will no longer it will never delete basically a file that you set by using this option. For more detail about how all this works, just read through these sections. Everything's explained in there. But yeah, I'll leave it at this when it comes to the workflow. So there's also a few things that I wanted to mention when it comes to the format of the reorder file. And this is sort of like edge cases, but yeah, I thought I would still explain this. Basically, reorder file has this format. What we just saw was a very simple format. It was like one file name per line. But the thing is that like there can be also a new line in the file name, which is a crazy file name, but it is a valid file name. So if that happens, let me see. I'll just trying to find like a folder here somewhere that I had with examples for this. Yeah, here it is. So here I have a folder with a similar file set, but there's also 3 additional files with like unusual characters. We have this file with a new line in the file name. Then we have this file with a backslash in the file name and with a number sign at the beginning of the file name. So now if I run fixeddigits-o on this, you can see that well, I forgot to do something about the new line one, but the backslash one and the new line one got represented like this. The new line is represented as \n, and the backslash is represented as a double backslash. So kind of standard, typical escape sequences. But the new line is the only special character that, at least at this point, it gets converted into this format. And so in order for the escaping to work, I also had to make a backslash a special character, of course, because it's the escape character. Now, yeah, I forgot about the number sign. So for that to match, I'll have to adjust the -b option and set it to a different regular expression to allow for the number sign to be at the beginning of the file name. If you haven't seen the first video on fixed digits that I did where I explained how to match the file names, essentially this is just the part of the file name before the numbers. These are the B and the A options, the match before and match after. I did a video on the first version of fixed digits where I explained this in a bit more detail, but this is basically it. It's just a regular expression matching the part before the numbers and the part after the numbers. So I need to match that number sign so that it also is included. And if I do that, then basically the number sign at the beginning of the file name, only at the beginning, also needs to be escaped, because otherwise it can be like either a comment or a gap line. So if a line begins with a number sign, it's either a comment or a gap line, and if it doesn't match the gap line format, then it's a comment basically. So this is a comment. This will just get ignored. So yeah, that's how that works, and you can see that the special characters are also highlighted in the output here as well. And you can find more information about the reorder file format in this section in the man page, but I basically just explained all of it. So yeah, but you can read through this, and yeah, it's there for reference. So yeah, like one last option that I forgot to mention when I was explaining the shift option. Essentially, this might come up, this is just another edge case, but there's also this match sign option, and what this is for is like essentially, let's say, let's see, yeah, I'll just go back to our original file set. So let's say I do fixed digits -s minus 3 on this. So in that case, these numbers will become negative. And so basically, if I go ahead and rename this and I have file names like this, what match sign does, it just allows for that minus to match as well. So if I don't specify it, it doesn't see the minus. but if I do fixed digits match sign, it works, and you can do like basically shift it back to like it was. So this is just like for compatibility, basically, in case you have that. Like I don't know like if there is any practical use for it. Maybe there is, I don't know, but like it works. It's there, more of an edge case, but yeah, there you go. So let's see. Basically, yeah, I've explained all of the new features that I introduced in this update. So yeah, I hope you like this new tool. I personally find that I just really wanted to have a tool to be able to, like, if I have a set of numbered files, just to reorder them conveniently without like doing any like complicated maneuvers on yeah, on the command line. I just thought of something real quick. So like, let me just show you. This is just a quick thing, but if you have a set of files like this, for example, where like they're all named the same except for the number, like look what happens when, let's say I wanted to swap 1 and 2. So I'd have to go like mv1 test 2 test, but like I can't do this. I would have to create a temporary file name, and then I would have to go like, okay, now mv2 test to 1 test. Okay, that name is now free, so that's gonna be okay. And now like mv 2 test underscore this one to 1 test. So this is just like such a pain to do, and sometimes you kind of come across like you just want to like organize your files a little bit better, and you end up doing this like convoluted thing. So just to kind of mitigate that, I figured I'd write this tool. With fixed digits, what you can do is simply, let's see, so I don't want to add the zeros here, so I can get rid of that. And so I can pass dash O to it, reorder it here, save and quit. So now it swaps the files, and now we can see in the previous CMD output what it does. Like it actually, like I implemented this so that it swaps the files correctly, creates a temporary name, and then swaps them and then renames them at the end over here. So you can see how that works. So yeah, that's the kind of thing that I wanted to make easier by writing this tool, and yeah, I hope you'll find it helpful as well. So yeah, this is basically it for this video. Thanks for watching. I hope you found this interesting and valuable, and I will see you in the next one.